power rule, which said the derivative of x to the n was equal to n times x to the n minus 1. So I'm going to just do this example. I've got some stuff we're going to do in class that you get some practice, but rather than me just do it all. But I want to cover some material in section 3 before I hand that out. So what you do first, in terms of if I had this function 3 over 5x squared, the first thing you do is you would factor out the constant, which in this case is the fraction. So then I have, so this terminology here, what this is saying is I'm taking the derivative of this function with respect to x. So let me go back here and add a page and just explain that for a second here. Up to this point, we might have said f of x equals 3 over 5x squared. What is f prime of x? And then we would figure out what it is. Okay. In this case, what we're saying is the function is the thing that's in the brackets, and we want to take the derivative of that with respect to x. So what I'm doing here is I'm taking the constant that's in the function, the original function, and factoring that out, basically. So then you end up with that. Okay, so we haven't taken the derivative yet. We've just said we can always bring the constant out front. Once you've done that, then you have to rewrite this as a x to the n type expression. So we would say we have 3/5 times the derivative with respect to x of x to the minus 2 power. So now it's in x to the n format. Then you use the formula. So you apply the power rule. And the power rule is, I'll write that over there, it says that the derivative with respect to x of x to the n is equal to n times x to the n minus 1. So the derivative of x to the minus 2 is going to be negative 2. So I'll put my constant here. I'll put negative 2 in parentheses times x to the n minus 1, which I'll then go ahead and multiply out the constant. So I'll get 6/5 times negative 6/5 times x to the minus 3 power. So that's where you do the differentiation, is when you have it written in the form of x to the n. And then you don't leave it as that. The final step is to move the exponent to the numerator, to the denominator, to make this positive. So the final step is negative 6 over 5x cubed. So what we would say is the derivative with respect to x of the original term, which was 3/5 3 over 5x squared, is equal to negative 6 over 5x cubed. Likewise, if I asked you, I gave you the original function, I said, what is the derivative? Then you could, write that as well. Okay, so let's, looks like everybody stopped writing. The last thing that's covered in this section is just this concept of average rate of change, and it's what we've been doing in physics when we talked about average velocity or average acceleration. So instead of giving, what we've been doing here with the derivative is basically finding what we would call the instantaneous rate of change. But if you wanted to find an average value from two values in space, all you do is basically find the slope of the line between those 2 points. That'll give you the average rate of change. So that's what's shown here. I think I have one homework problem. I don't test you on this, but it's in the book. So it's basically saying you start at this point, x1, y1, or f of x1, and you go to some point x2, f of x2, The average rate of change is just defined as the change in y divided by the change in x. And what we've done for the derivative is we've taken the limit of this expression as x2 and x1 approach each other, and that gives you the instantaneous rate of change. Okay, we'll just skip over that stuff. Yeah, that's it. And there's your homework for section 2, which did I already sign? I already signed that, didn't I? Yeah, because there was a lot of, I remember there were a lot of problems. Okay, move to section 3 here. We'll introduce the multiplication rule. So section 3 deals with what are called the product and quotient rules. So up to this point, what we know is, what do we know at this point? We know that the derivative with respect to x of a constant is 0. We know the derivative with respect to x of a constant times some function is equal to the constant times the derivative of the function. We just use that. We know that the derivative with respect to x of a power is the exponent times x to the n minus 1. And we know that the derivative with respect to x of the sine of x equals the cosine of x. And we know that the derivative with respect to x of the cosine of x equals negative the sine of x. Okay, so that's it so far. So what we're going to do now is we're going to look at what if we have functions that are products or quotients of trigonometric functions or polynomials. I guess the other thing we know is that the other thing we said was that if you had the derivative with respect to x of two functions added together, that's equal to the derivatives of the functions by themselves. That's the addition rule. So if we have a polynomial which has multiple things of x to some power, we just take the derivatives of each one separately. Let's just do that. Let's demonstrate that before we move on here. So let's say I had f of x equals x cubed plus 2x squared minus 7x plus 10. And I said, what is f prime of x? So in this case, we've got a four-term polynomial. The rule at the bottom says all we have to do is take the derivative of each term and add those derivatives together to get the final polynomial. So we apply this rule to each one of these separately, and that's all there is to it. So the derivative of 3x squared, well, let me just ask somebody here. So Jacob, what's the derivative of 3x squared? I mean, pardon me, I just told you the answer. What's the derivative of x cubed? There you go, you were at least paying attention. Yeah, 3x squared, yeah. That was okay, let's go next year. Here we're going to pick, who haven't we picked yet? Tessa, what is the derivative of 2x squared? 4x, good. And let's see, Seth, what's the derivative of negative 7x? Okay, so if you had x is x to the first power. So if you use the power rule, what would you get? You'd have you'd have, what's n? 1 times x to the 1 minus 1, which is 1 times 1, which is 1. Okay, so anytime you have x, you just drop the x. Okay, that's you'll find that easy. So it's just -7. Okay, so anytime you take the derivative of a variable that just has the variable by itself, just drop the variable and you have the constant. And the last one is 0. So the derivative of a constant is 0. So there's your answer. You wouldn't leave the 0 in there. You just say it's 3x squared plus 4x minus 7. So anytime, if you have a third order polynomial, the derivative is a second order polynomial. If you have a seventh order polynomial, the derivative is a sixth order polynomial. Every time you take a derivative, the polynomial decreases by a order and your constant drops off. Okay, so let's move on here. So where's the I don't want to do the quotient rule yet. I don't know what happened to the product rule, so let me write that out. So the product rule says that if you want to find the derivative of a product of two functions, that's equal to the first function, but no derivative taken of it, times the derivative of the second function plus the derivative of the first function times the second function. So it's not f prime of x times g prime of x. It's f of x times g prime of x plus f prime of x times g of x. So let's use a example here. Let's say I want to find the derivative with respect to x of x times the sine of x. So that's a product. So I'm going to write the functions down here. F of x would be equal to x, and g of x would be equal to the sine of x. So the derivative f prime of x is going to be 1, and g prime of x equals the cosine of x. Okay, so we use the power rule, but we just said anytime you have a variable and it's raised to the first power by itself, the derivative is just 1, and we said the derivative of the sine is the cosine. So to find the derivative of this, you just plug these plug the things in you've got here. So f of x was x times g prime of x, which is the cosine of x, plus f prime of x, which is 1, times g of x, which is the oh, I did something wrong here. No, I didn't. Wait a second here. Yeah, f prime of x, 1 times the sine of x. So you almost, if you set it up this way, you're just kind of cross-multiplying so you take the upper left times the lower right, plus the lower right times the lower left times the upper right, like that. That's the product rule. And again, you would simplify by getting rid of that 1 because it's not really useful. So I'd write x cosine of x plus sine of x. Okay. Now I'm going to prove why this is true. Hopefully I can do it without looking. So the way you do this is what we're actually going to say is we're going to say h of x is a product of two functions, f of x times g of x. So what I'm looking for is what is the derivative of this product. H of x is a product of these two. So what you do is you take h of x plus delta x using the limit definition for the derivative. So we have f of x plus delta x times g of x plus delta x. So we're just plugging in x plus delta x into the function. Now in this case, because these are just general functions, you don't actually plug them into a function, but you'll see it'll all work out in the long run if I do it right. So the limit definition says the derivative, so let me do this again. So h prime of x, the derivative of the multiplication function, is going to be equal to the limit as delta x goes to 0 of h of x plus delta x minus h of x. So that's the same definition we used before, except I'm using h instead of f. Doesn't really matter. Okay, now I plug in what they are. So let me just put an equal sign here. I need all the room I can get. So you have the limit as delta x goes to 0 of h of x plus delta x, which is f of x plus delta x times g of x plus delta x minus h of x, which is the product of the two, all divided by delta x. And you can see that when delta x equals 0, you end up with an indeterminate result because the first two terms in the numerator become the same as the second term, the f of x times g of x. If delta x is 0, then it just becomes f of x. So you have 0 divided by 0, but it's not obvious. How do we cancel things out? How do we divide things out? So what we do is we, okay, this is a part I got to make sure I do right. We're going to add and subtract the same quantity to this function. And what we're going to do is we're going to take f of x, actually we're going to f of x, what it is, it's either f of x times g of x plus delta x, or it's the other way around. I got to remember the way I do this. So it's going to be f of x times g of x plus delta x. Okay, yeah. So what I'm going to do is I'm going to add that, and I'm going to subtract it, the same term, because if I do that, then I'm not changing anything. And what you can do is we're going to group these two together, and we're going to group these two together. So let's do that. So we're going to take the limit as delta x goes to 0. So the red ones together, let's put it in red, is you're going to have f of x plus delta x times g of x plus delta x minus f of x times g of x plus delta x, all divided by delta x, because I've got this plus and this minus. Now here I'm going to have, this is going to be the other way around, so let me do that with green. So then what I'll have is plus the limit as delta x goes to 0 of f of x times g of x plus delta x minus f of x times g of x, all divided by delta x. Did I do that right? Yeah, it looks right. And then what I can do is I can factor out g of x plus delta x here. So you'll have the limit as delta x goes to 0 of g of x plus delta x times f of x, f of x plus delta x minus f of x divided by delta x. And then the second part, I'll factor out f of x instead. So I'll have f of x times g of x plus delta x minus g of x, all divided by delta x. So the indeterminacy is in this part right here, in the second part. Let me just disconnect myself for a second. So this part is where the indeterminacy is, because if I let delta x go to 0, this will be 0, and this will be 0. This won't be 0. So because this is not, there's no indeterminacy, I can actually take that outside of the limit. The same here, I can take this outside of the limit because it's not indeterminate, and then I can use the definition of the derivative of a function to rewrite the whole thing. So let's just do that. Well, what actually happens is, let me do this. You don't have to worry about deriving this. It's just to show you where it comes from, that it is using the limit definition of the derivative. So what you'll end up with is when you let delta x go to 0, that just becomes g of x. And then you'll have the limit of what's left inside, which is this difference. And the same thing on the other one. When this comes outside, it'll just be f of x. And the second term will be the one where the limit's applied. And I should have done it in green, but that's okay. You don't have green pens, so. But by definition, this is f prime of x, and this is g prime of x. So we can then write the final answer. So what we have is we have g of x times f prime of x plus f of x times g prime of x. And there you go. That's the product rule. Okay, so we didn't use a specific function, but we did this adding and subtracting the same thing, grouping the terms, and we were able to get rid of the indeterminacy just by saying that that's the definition of the derivative. Okay, so that's the product rule. And you can do the same thing for the quotient rule, but we're not going to do that. We're just going to tell you what the answer is. So there's the quotient rule. So if you have a quotient of two functions, it's a little more complicated, but so you have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared, except g of x cannot equal 0 or your function's undefined. So let's use the same two functions that we just looked at. So let's say h of x equals the sine of x divided by x. So I'll let f of x equal the sine of x, g of x equal x, f prime of x equals cosine of x, g prime of x equals 1. Again, this is using the formula that we know. This is using the power rule. We just plug them into the formula. So we know that h prime of x equals the cosine of x times x. So we take this times that minus the sine of x times 1, all divided by g of x squared. And sometimes you can simplify it. The only thing you really can simplify here is one is you typically, if you have a product of a polynomial and a trig function, you put the polynomial first, and then the second one I could drop the 1 and divide by x squared. I'm going to turn my email off so it doesn't keep popping up here. Okay, so that's the product rule. So what I'm going to do is I'm going to hand out something. We're going to do some stuff from the last section, and then we'll do some product and quotient rule problems. So let me see what I'm doing here. I guess I'm disconnected. So who are you guys playing tonight? Rockridge. Oh, yeah. Okay. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12. How was the drive?
Wasn't too bad.
Wasn't too bad?
Yeah, stayed in Roanoke, so
Oh, okay. That's good. Okay. So the first problem is just using the power rule and the constant multiplier rule. The second one is just like we did, where you have to rewrite it before you take the derivative. Excuse me. The third one is don't use the quotient rule. What you can do is you can rewrite that as three. You can simplify it into three terms, and then you take the derivative of each term separately. The fourth one is just a polynomial like we just did a few minutes ago. So we've done all of this stuff. The last one on the first page is the product rule, but you don't want to multiply it out. Don't use FOIL. You could use FOIL and then take the derivative, but I want you to use the product rule. So f of x will be x squared plus 3, and g of x will be x squared minus 3x. So, excuse me. Yeah, for all of the initial problems, the only rule that you need to know is that the derivative with respect to x of x to the n is equal to n times x to the n minus 1. And make sure on the second problem you rewrite it initially as 7 times x to the minus 3 power. So in that case, n is equal to negative 3. So there's the answer for the first one. 3 times 1/3, they cancel out, reduce the exponent by 1. Remember, n minus 1 is negative 3 minus 1, which is negative 4, not negative 2. So when you take the derivative of this should change not to negative 2, it should change to negative 4. So you're done the first page? Yeah, if you want to, because I know you've had some of it already. So, oh, this one, yeah. So what you're going to do is you'll have this x. Well, you have to divide out by x for each term. So you'll end up with 2x for this term, -3 for that term, and 1 over x for that term. Yeah.
Once we get here, we're supposed to FOIL everything out, right?
Uh,
Or no, you don't want to?
oh, to simplify, yeah,
Okay.
yeah, go ahead and FOIL it out and simplify it.
Okay.
Yeah. Oh, yeah, let me look here. This one you're going to need to rewrite as x to the
-1.
1 power. And so this one's done and that one's done. And you just need to take the derivative of that.
Okay.
And then you should have an equation. I'm not sure what you're doing there.
Okay.
You should have 2x minus 3 and then one additional term. And then this one is 16x. Yeah, that's fine. Yeah, when we're working like this, if you want to talk to your neighbor or just as long as you're working on the problems and somebody can help you besides me, that I don't have any problem with that. It's just when I'm talking lecture-wise, that's when I don't like people talking. So the answer for the second one is -21 over x to the 4th. The third problem, you'll simplify it by dividing every term in the numerator by the denominator. So you end up with this. So you can't just divide it out one time. You have to divide every term. And then what you'll do is you'll rewrite the last term as x to the -1 power. And then take the derivative of each one of those. Seth, what's the derivative of 2x? Yeah, good. Okay, we still have the 3. So you took the derivative. Well, you're right. The derivative of 3 is 0. I don't know why I said that. Ignore me. On the last problem on this page, yeah, actually, the last problem on the first page, I'm going to multiply it out, which I'm telling you not to do, and I'll give you the answer, which you should get from doing it using the using the product rule. So I'm going to use FOIL to get the, it's probably actually easier to do it that way, but that's not the point right now. Oops, did that wrong. So that's the answer for the last one. Not the procedure, but the answer. Did anybody get that yet? So what you're supposed to do is use the product rule, then multiply it out and simplify it. So yeah, that was the right answer. So this is the way you, okay, let me give you the answer. I'm pretty sure everybody got the answer right for the fourth order polynomial, but I'll write it out. So here's the answer to that. Okay, looks like most of you are getting the next one done, so I'll go ahead and work through it. Is that what you guys got for that one? Okay. So we're going to stay in here again for physics. So when we finish, we'll work till 9. Then you can have your 15-minute break. Be back. So on, just to give you a little head lead here, you're going to convert the cube root to x to the 1/3 power. So this will be f of x, this will be g of x, and then you have to use the quotient rule, which says h prime of x equals f prime of x times, oh, I'm going to double check, make sure I wrote that down right. Let's see here. Quotient rule. Yeah, it is f prime of x. Okay, we're good. So here's a political commentary. So when Obama was president and there were hurricanes, you would hear certain people from